development with Haxe and a new lib that, or a set of libs that I've been working on called Grig. And I have a little sticker for it right here if you want it. I put stickers on the swag table over there. Um, so basically, when I say audio development, I'm not just talking about like playing background music or playing a sound effect at approximately the right time, but also being able to create effects or synthesizers or other sorts of audio or music application. Um, just a little bit of background. What prompted me to start working on this was last year I was here in Seattle and I did a talk about how Haxe is good for applications with multiple components, like a server, client server. And as an example of what not to do, I talked about a audio music application I worked on in the past, and that got people interested because I'm a Haxe developer who also does audio, and so I thought I'd try my hand at doing some audio stuff in Haxe, and I found that some of the basic infrastructure that I would have expected to be there wasn't there yet. So instead of working at like the higher level, like making synthesizers and generated music and cool stuff like that, I needed to get MIDI I/O and audio I/O working first. So that's kind of the thing that I focused on in the little bit of time I've spent working on this. This is not my full-time thing. I'm a freelancer, so it's more like in my non-existent free time. Over the past half a year or so, I've been working on these set of libs. So with that, so yeah, here are just some screenshots of what I'm talking about when I say audio programming. I've actually had some people kind of not get what that is. Like they think that, oh well, everyone knows how to write, play MP3 or whatever. But you've got DAWs, stuff like that. And I would like it if Haxe was a platform that you could use to make DAW. Another thing is, I think there's this idea out there that Haxe kind of has fun stuff, fun creative stuff covered, and we need to cover more serious stuff to reach out into more serious, like business-oriented markets. And my response to that is twofold. First of all, I would say we don't quite have the music thing covered. That's a creative thing that we haven't really cultivated yet. And also that audio is not just a creative thing; it is a beat. Audio processing is used in various fields, not just for making music or cool sound effects. It's something we might also use when processing any kind of audio data. Use it in sciences, use it in forensics and stuff like that. And also when you make frameworks, that is, your programmer making code, the idea that other programmers use that code, that's a business-to-business product, even if it's for an entertainment-oriented in this use case, ultimately. So why would I bother to even try to use Haxe to do audio? I mean, I have so much, I know how to write code in C++ and for C++ and even JavaScript and Python, the stuff is already there. Well, I would just say that for the same reasons I like Haxe for non-audio applications, it has potential for audio applications. It's multiple, you can have multiple different targets. It can defer target or environment is like a optimization step made later, not something they have to choose at the beginning. You can just write in Haxe and then later decide if you want to optimize for C++ or JavaScript or whatever. Another cool thing is at least several of the targets that Haxe targets are languages that have a lot of an active audio development community. So if you're targeting CBP, you make externs for all of that already existing audio code that's out there, like that open source audio code that's already out there in C++, or even if it's not open source, if you're using something proprietary, make your own externs for that pretty easily because Haxe has a CPU target. The same goes with Python. There's also an active community there. Python's popular in academia. There's a lot of like music theory stuff written in Python, and you can, at the very least, make use of that by targeting Python and making extern whatever it is you want to do. But it's also cool if you can use Haxe to make things that those communities might make use of. Another thing, and this is more of a theoretical point because I don't have like I don't have something working yet that proves that this actually helps, but you can use macros in Haxe to see what you're doing and prevent some high level unoptimal situation. You could, for example, make a macro that says, do not, call new in this code because it's an audio callback. So at least theoretically, you can do things like make sure that your code is appropriate to be used in audio context. So if you're not familiar with writing like real-time audio code, probably the most important thing is that you don't have underruns, and then if you do have underruns, that you can handle it gracefully. So as far as not having underruns goes, you need to make sure that you're not like allocating or deallocating in there or doing file I/O. You can at least potentially catch some of that with, not all of it with macros. A lot of the target implementation details though aren't really necessarily known to Haxe, so could still be something bad happening. So this isn't like a guarantee, but one potential path of optimization. And just as I mentioned before, so while Haxe might not have an extensive audio developer community, it is at least an advantage that there's a lot of game people working. Game programmers like audio. At least audio is a necessary component of what they do. So I think that there's an asset there. We already have game programmers. We just need to add audio programmers to that mix. Good things will happen. The type system does allow for some generic algorithms. You could do the same thing you do in C++, where functions take a type parameter. Also, you use macros if that doesn't provide enough flexibility. And while there isn't a lot of stuff made for the purpose of writing audio applications, there is a lot of audio stuff in there for game developers. You already have bindings for OpenAL and have kind of a lightweight implementation of OpenAL in heaps that you could use on platforms that don't have that. You have stuff for loading audio files as well. It also has some disadvantages. So here's some of the kind of frustrations that I ran into while trying to write some audio stuff in Haxe. So the first one is no MIDI I/O until now in two parts. One is as of very recently, the latest version of Haxe has externs for Webb MIDI built into it. So if you're targeting the browser, you have externs for MIDI now. So if you go into api.hex.org and select the latest version, and you search for MIDI, your hits are all going to be on the JavaScript. Then additionally, in Grig, I now added externs for MIDI as well. So now target CP or Python or Webb JS or Node.js, and in all those platforms you now have MIDI I/O. So you can now connect to a keyboard, listen in on it. That doesn't seem like a big deal, but that's kind of like a requirement before you can even start synthesizers and digital audio workstation. The other is no Pro Audio appropriate audio I/O. We have had audio I/O for a long time. Thanks, I really need that. So we've had audio I/O for a long time, but like I mentioned, it's OpenAL based. It's like abstractions for OpenAL. OpenAL is cool, but it's not really designed for audio application. What you need when you make a real-time audio application, especially, is a callback-based system that gives you timing information. So you need to know, like, when you get the next callback, is that sequential, or what that I take so long in my last callback that I missed several callbacks? So that's kind of what I already said about, the most important thing is to not have underruns, but if you do have underrun, you need to handle it gracefully. So if you're doing something like live or whatever, and your computer just kind of chokes for a second, you don't want it to suddenly be out of sync with the video or out of sync with the rest of the music. It's going to sound bad. So port audio, that's a cross-platform audio library, if you're not familiar with it, that forwards that information from the native APIs such as ASIO or Copy or ALSA or whatever. It forwards that to you, and then Grig also forwards that to you when you're using Haxe. So you now do have audio I/O that you can use for Pro Audio stuff. Also, just like with the MIDI I/O, Haxe does now for Webb audio. Actually, no, I might have had that for a while, but I abstract that so you can fit in the same callback-based system. The other is just Haxe by its design as a garbage collected language, and that's kind of a mixed blessing with audio code. Allocating and deallocating is expensive, of course, but also suddenly having an unexpected garbage collection in the middle of audio callback can also cause an underrun. So I'm not sure that there is a good way to address this, because it's kind of like, even when you're targeting a non-garbage collected language, you kind of still have to have the garbage collection there. But it's just something that you have to kind of work around. It does make like a really low memory context kind of hard to work with. A lot of traditional audio programs, you allocate everything you need at the beginning, and then from there on you don't do any allocs or deall or freeze. You just use that same memory over and over again. And it's just, I don't think it's really possible to have that kind of control in Haxe, but there are some ways around it, so it might not be that big of a deal. And I do mention that it's garbage collected even when you're targeting C++, but there are some options you have, both with HXCVP and HashLink. In both cases, you have some different options available to you. I think HashLink even lets you feed it a garbage collection system, but I haven't played with that yet. Then the other one is, this is kind of good and kind of bad because it means you have more options, but we have two compiled C++ or C targets, and that kind of means, for me, I have the MIDI and audio I/O for CPP, but I should probably also have it available for HashLink. You can't really use the CPP version with HashLink, so if someone wants to write an audio application with HashLink, currently they can't really use Grig. I need to get around to adding that support, so that kind of increases the amount of work for me if we want to have, audio, MIDI I/O, and other kinds of target or environment specific stuff more widely available. The other is there's no. This might seem like a minor thing, but it's kind of annoying when you're writing audio code, especially like converters and stuff. We're trying to write more generic audio code, but in C++, what you can do is you can pass in a type to numeric limits, and you can, like an integer type or any numeric type really, and you can get the max value or the min value. So when you're dealing with integer audio, it's always going to be in the min min value to max value range. Not for floating point. Floating point's always going to be like 0 to 1 or -1 to 1. But if you want to say convert between 16-bit audio and 32-bit audio or 16-bit integer and floating point, it's very handy to be able to get those max and min values. And yes, you can just hard code it, but in C++ you could kind of make a generic function, and it'll do the right thing based on whichever type you passed in. And it's kind of frustrating that I don't have that in Haxe. And then the next one is some targets are not well suited to use from that target language. So one use case for Haxe is I write code in Haxe and then I create an application. The application is a black box. It's not really meant to be used directly by programmers. It's meant to be used by the end users. But another use case is I want to transpile to a given target, and I want coders in that target to be able to use that code, that generated code. But OpenFL is a good example of how that idea is used well, because you can use OpenFL in JavaScript, and that's pretty freaking cool. And JavaScript is one language where I would be comfortable, taking the Haxe generated JavaScript and shipping that to NPM or whatever. And if you're not satisfied with Haxe's own JavaScript generation, you can even use like hxgen.js, which is like a separate project that does its own, like splits it into multiple modules and stuff like that. So you have a lot of options for JavaScript. But then like with Python, Python started out as something that was written in Haxe that used the custom hook to be able to make custom JavaScript output, and it kind of shows it's still like it puts all of the Python code in one file, and that's fine if it's just an executable and you're running it, but it doesn't lend itself to shipping that as something that someone can install with pip install. So it would really entice, I think, more audio developers if you want to write JavaScript, if you want to port this audio code to JavaScript. I think already Haxe is a good way to do that. Just write it in Haxe, and then it's a better way of writing JavaScript. But if we could also tell those people, and hey, you get Python 2 for free, then it's like that's that much better than writing it in TypeScript or just JavaScript. And then also this is not really necessarily a flaw in the implementations. It's just kind of the way it has to be. But generated C++ or C code by the PAL targets are just not really suitable to directly use the way you would normally use like a C++ library. It kind of has to be that way because Haxe is garbage collected and stuff like that. But that is one thing that a lot of audio programmers might not like. They use C++ a lot, and they might not feel secure if they're unable to use the Haxe C++ output in a C++ program. There are ways around it. You can make like a C interface for it, but it's not like super straightforward. And another one is so the basis of a lot of audio code is digital signal processing, and we just don't have like a wealth of DSP. We have hardly anything, actually. Like there's just a lot of basic stuff that we need to have, like just FFTs, and filters and stuff like that. And then kind of the next frontier in audio or image processing, for that matter, is machine learning, where you run DSP first to get like features, and then you feed it into a model, and you can do things like filling in the blanks or predictive analysis. I think you can use like machine learning techniques to make like virtual instruments that sound realistic, or even like singing speech synthesizers. And if we had more of that stuff, that would be awesome. If we at the very least had externs for more of the stuff that already exists, that would also be cool. Like, Python already has so much stuff. Haxe already has a Python target. So if we had like externs for scikit-learn, that would also kind of go a long way too. And this is kind of a small point, but just going through like what's already there for loading audio files. I see a lot for MP3 and Wave and Vorbis, but Vorbis is kind of like being replaced with Opus. That's the sort of successor to it, and it's better than Vorbis in so many ways. And I wish that Haxe had something built in that I could use that's just written pure Haxe code. But I couldn't find anything for that other than like there's like one lib I could find that was like written for OpenFL, but it was just like only exposed a few functions. It was just extern for the CPP target. Okay, so now to talk about Grig, the thing that I started working on to address some of these issues. So it's a set of libs to facilitate making audio applications using Haxe. And I hope down the line that it also helps facilitating writing in other languages that Haxe targets as well. But right now the main focus is Haxe. As much as possible, I make the code target neutral. So something like loading an audio file or whatever, I try to make that just pure Haxe so that you could even use that in context I wouldn't even imagine, like loading on an audio file in a PHP without having to use like a C extern, a C binding or whatever. And then for things that just have to be target specific, I try to support as many platforms as make sense. I mean, some platforms are just like, I don't think anyone's going to write like a synthesizer in PHP probably, so I don't really focus on that. But I do want like the compiled targets and Webb, and plugins. Those are the things that I want to like cover at the very least. Then I also just whenever I try to make something open source that's Haxe, I just try to do things the Haxe way as much as possible. Just idiomatically do things the Haxe way, and I do things like the new Haxe way. So Grig is all like, it uses the latest version of Haxe. I don't even know if it works in 3. It's designed just for Haxe 4. It uses, if you clone any of the Grig projects, they all have like a .haxerc, so it's designed to work with licks. So you don't have to manually install anything to work with it or invoke Haxe Slide. You can just do licks download, and then you're good to go. You should be good to go at that point. And yeah, it is an early stage of development. There's some important things it can already do, but it's like definitely less than a year's worth of effort. A year less than part-time worth of effort. So here's just an overview of some of the different parts of Grig that I have so far. I should also mention the Grig is, if you're not familiar, if you're not like a nerd, it's like musical cricket fairy like in D&D universe, and it's kind of this, like the Tinkerbell library that's named after a fairy too, so this is also named after a fairy. So as an overview, so Grig.audio, the main thing that provides security is a cross-environment abstraction for an audio callback. So on environments where it's available, it abstracts to port audio. Then on the web, it directly uses web MIDI, but it abstracts over like the script processor, I believe. It also just provides some containers that represent audio signals. So basically, multiple channels of audio data, audio buffer, audio channel. It has a start of some audio routines in there, but it's got a ways to go in that respect. But there is at least resample using using linear interpolation. So that's something I added recently just because I needed it for an example. And then Grig MIDI is equivalent to that. The main thing that provides is a MIDI callback. It uses RT MIDI and platforms where that makes sense. It abstracts to Webb MIDI on the web. It also can load and save MIDI files. And then in both of those, Grig.audio and Grig.MIDI, those are both in HaxeLib, and I actually did a new release to HaxeLib of both this morning based on some fixes that I made for some of these examples. Grig.pitch I haven't released to HaxeLib yet, but I guess I could. This is pretty basic. All it does currently is it just has classes representing different keys, scales, notes. The main thing it does for you is you can give it like a MIDI note and it can tell you the pitch for it, and it provides different tunings. So you can do equal temperament where it's all like evenly spaced, or you can do like something more obscure like Pythagorean temperament or whatever. So that's all in there. That's pretty straightforward. That's just pure Haxe. There's no externs or anything in there. Should work in all platforms, all targets. Grig.plugin, that's also a work in progress. That is not in HaxeLib yet either. But currently that provides a low-level API for creating and hosting plugins. So the current thing I'm working on is getting support for LV2 plugins working. That's a little bit easier because it's like an open source format. But down the road, I want to also support VST and AU, the two more popular formats. But right now, that just provides a low level, and then once that's finished, then I will get Grig.audio and Grig.MIDI to abstract over that, and then that'll add another environment that those support. Grig.synth is also not really ready for prime time yet, but that has like a modular synth in it, and it also has a port of libfm synth, although I might not end up not needing libfm synth because I just, one of the examples I made is an FM synth that works better already, so I might just kind of make my own from scratch anyway. And then if you clone just the Grig repo, all that's in there is just examples that depend on multiple subprojects. So if an example only needs Grig.audio to work, then it's going to be in the Grig.audio repo. But if it needs Grig.audio and Grig.MIDI, then it's going to be in the Grig repo. So that's where like the synthesizers are, because those rely on Grig.audio and Grig.MIDI. And then Grig.tech, that's just that's not really a lib, that's just the website. But I made my own static website generator using Haxe React. So that actually, Grig's website is generated on the fly on NetLifey, and it doesn't even, that service doesn't even know the existence of Haxe, but because of Haxe's integration into the JavaScript ecosystem via Wix, I can trick something that's designed for working with JavaScript-based static website generators into bringing down Haxe and culling docs and all that. So that has like the docs on it as well. And that's a joke you only get if you're a synth nerd. So here's, so if you go to the Grig.tech website, it has a longer table that shows more of the stuff that I want to get to, but this focuses more on what's already there or will be there soon. So I think I already mentioned all these, but basically, oh, I actually didn't mention keeps yet. So anyway, the check marks is where it's implemented, and NA is where it doesn't even make sense. X is where I gave up temporarily. So CPP standalone, you got audio and MIDI IO. LV2, that's the thing I'm currently working on. HTML5 works, it works pretty well even, I should say. Node.js, I couldn't really get the already existing bindings to port audio on Node.js are stream-based, so it doesn't really work very well with the callback. I'm not even sure that a callback-based thing would work, because when Node.js binds to C++, it just has to run everything in the same thread. So I couldn't really find a way to modify what already exists to notify often enough to do like an audio callback without like really slowing down the main process. So if someone is more of an expert at doing Node.js to C++ bindings, maybe that person could tell me if I'm doing something wrong, or tell me that, yeah, what I'm trying to do won't work. But if you want to make audio application based on Node.js standalone, that's missing. Although I don't know if that use case is worth pursuing or not. I don't know how common it is for people to write for that case or not. Python, though, you can write an application, you can target Python and have access to MIDI I/O and audio I/O. In that case, it's just using Python's bindings to the respective C or C++ libraries. Heaps is interesting. Obviously, Heaps doesn't provide MIDI I/O, but you have an abstraction over Heaps' like audio channel. If you link to Heaps and to Grig.audio, then the Grig.audio callback is actually abstracting over audio channel. So you can take your same audio code and now you can run it in game engines. Because Heaps also abstracts over OpenFL. So this also allows you to use that same audio code in OpenFL even. I have an example somewhere of doing that. And as far as the ones that I want to get to, I think C# would be cool, and more plugin formats would be cool too, and more game engines. I thought I'd also mention that Haxe plus Grig isn't the only way to write audio code once and then get code in multiple different environments. There's at least two others that are worth mentioning. One is called Soul, and that's an early stage of development, but it's by the same people who are behind Juice, which is a very popular C++ framework. But Soul is a language in and of its own right. It's audio specific, but it translates to C++ code and code in a number of some other languages. So you could use it to make something in JavaScript that you deploy to the browser. It also supports hardware DSPs. That's kind of that's a hard niche to get into, and it really is a niche. But you know, a lot of audio code still gets written for like specialized hardware even today. Then another one that a lot of people have compared this to when I showed to a Linux audio development conference a couple of months ago is Faust. Faust is an audio-specific functional language, so that all the data is like immutable or whatever. So both of these are not general purpose like Haxe. But Faust is also kind of cool. You can use the same code to make like a desktop synthesizer or something that runs in the web, or something that works as a plugin, and they already have the plugin formats like covered pretty well. So that's pretty cool. But what's cool about Haxe and Grig together is you have a general purpose programming language that can also target all these different targets. Okay, so after this is excellent. Okay. So yeah, just some more stuff that I would like to get to in the next couple of months. I'm pretty good at keeping stuff that has to get done or bugs. I always put those in GitLab. So the primary hosting for this stuff is GitLab, although it's all mirrored on GitHub, but all the issues are on GitLab. And they're also organized into the specific repos. So anything in Grig.midi is going to be Grig.midi's issues section. So if anyone wants to contribute, you can look at those issues and you can see the whole list right there. You can can also hop on the Getter. I'm pretty much always there, or at least my phone's connected to that, and I should see whatever message you sent to me. And as I already mentioned, I'd like to add more environments. I don't want to add like every environment possible. That's not the point. I just want to get to all the important environments. And the main important environments that are missing are plugins and game engines. Those are kind of the two big ones that come to me. Like being able to also have your audio code run like in the Fmod context would be cool. And being able to use that same code to make different types of plugins like VST or LD2 would be cool. And that's why I'm currently working on LD2 implementation. Another big one is more flexibility in audio formats. So currently the single one true audio callback is, what it gives you is channels of floats. And that is a popular format, but that's not the only format. If all you're doing is, say, loading a file and then playing it, then that might add unnecessary overhead because the file is going to be interleaved. If you can talk to the sound card and interleave as well, you can avoid doing an unnecessary conversion. So I'd like to make it where you can specify the format and perhaps even specify not only format as in layout in the memory, but also format as in float versus 16-bit int versus 8-bit int or whatever else. Giving more options means you have more ability to optimize, because it is more expensive to work over larger amounts of data. You do already have flexibility in terms of number of channels, input, output, sample rate, just not in terms of the data type yet. And the other is utility DSP and music theory stuff. So kind of what I've been working on now is more like the very bottom layer of the pyramid, which is the infrastructure you need to even start making audio code. But the next level above that is where I want to get to pretty soon, which is, stuff that you're most likely going to need, like stuff to make filters and just basic music theory stuff, so you don't have to like reinvent the wheel or whatever. And then, if there's stuff here that's valuable, not just to Haxe programmers, then I would like to also release some things as NPM modules as well. And that would kind of get more interest in the project. And then kind of the last one almost covers everything else too, but just using what I made to make something, which is kind of the whole reason I'm making this stuff, is to make it easier for me to make things and easily target multiple things. Because it's you go through all the work of making like a synth or whatever. Just releasing it on the App Store is one thing, but releasing it as an App Store and as a plugin, that greatly increases the potential market for it, and it's a crowded market. It's hard to make money off of music stuff, because just like everyone wants to make music, everyone also wants to make music software. And then yes, so I'm going to show you all maybe some examples. Oh man, I only have 7 minutes left. That's good. Yeah, I'm just gonna. So I'll just go into the Grig repo and just kind of go over some of the examples to just show how it works. Just show how you would go about using some of this. So it's easy to understand. Maybe this one. So here I've got one example that's it's called Mono FM Synth. It's a really simple FM synthesizer. So you basically have 2 sine wave oscillators. One you hear, the other modulates the pitch of the first one. And that's a very easy type of synthesis to do on computers. That's why we've had FM synth since like the early 80s or so. And you know, y'all might remember like old computers had FM sense built into them, or the Sega Genesis had one built into it. Because it's conceptually a very simple type of synthesizer for a computer to do. So here, so I'll show you the HXML first, just to show that this is building. So I'm building this example for Webb, JS, Python, and CDP on Windows. And I'm only relying on these two of my libs. And then I just made this HTML just for the JS example. So let's walk through a little bit. So we've got here like the two callbacks. So Haxe is cool. You can use like you can't really do this in C++. You can't pass in like a function that's a you can't call a method on a class as a function pointer usually, but in Haxe you can, and that's pretty cool. So this is my audio callback. It gets an input buffer that represents sound coming in from the mic. There's an output buffer that whatever I write to, that's going to go out of the speakers. It tells me the sample rate, and has audio stream info, and that's where timing information is and stuff like that. I'm not making use of it in any of these examples, but if I was doing something like making it a sequencer, then I could do that to make sure it doesn't fall out of sync upon underruns or whatever. And then I have something basic here to acquire a mutex if you're on a platform that has different threads. Because audio callback and MIDI callback are different threads generally. So those both happen in their own threads separate from the main thread. That's always something you need to keep in mind when you're doing audio programming. But it passes on that information to a separate object that represents the synthesizer itself. So that's where all the magic happens. And then, so here's the code to instantiate the audio system. Here's the code to instantiate the MIDI. It's a little ugly. So the way because I need to abstract over both JavaScript's way of doing things and C++ is, I kind of do things the JavaScript way. And I think that the JavaScript way is actually kind of cool. So something that's uncertain or might take a while, you just make that where it returns a promise, and then you can just kind of continue doing other things if it's not being done synchronously. So on the synchronous targets, CPP, it basically just calls it and then immediately returns. On the asynchronous targets, it can actually continue on, and then when they resolve, they call this code here. Then audio and MIDI both do the same thing. The thing worth noting is here is where I construct the options. So those are the options I want to open the sound, to talk to the sound card with. But I ask the audio interface what ports it has available. So you know, it's not even a guarantee that there is an input port or how many channels there are or whatever. So I look for what the default output port is, and then I basically just use that. And then I specify that I don't need any input channels because this is a synthesizer and I'm not doing any audio effects. I do have an example in here. Oh no, it's somewhere else. I do have an example of audio effect in grig.audio that just makes a kind of high-pitched robot effect or whatever. It's a very terrible, cheesy effect, but it's easy to understand what it's doing, at least if you look at it. So here's where all the fancy stuff happens. So, I don't have much time left yet. Oh, I have no time left. Crap. Okay. 5 more minutes. Yeah, maybe questions are better to do, because I think, yeah, I wanted, yeah, okay, fine, yeah, let's do that. Okay, so let's. I mean, there's not much to show there. It's just you're listening to a synth sound or whatever, but that's it, right? Basically. Oh, just my luck, it doesn't. Is it coming out? HDMI? I actually don't hear anything now. Huh?
I'm getting it, but not the speakers here. So it's on the stream. So listen to
Oh,
the
you know what?
stream.
Actually, let's just do this. You don't need to see anything now, so let's get out my itty bitty speakers. I think I need to restart because it was already connected to HDMI. Oh shit! Actually, yeah. Actually, I need to re-plug this back in so it has a MIDI. Okay. Okay, yeah. Unfortunately, it's not very impressive because it's coming out. But the point isn't the synthesizer. This is really the point is I just want to show how to make a synthesizer, right? Like this synthesizer isn't really part of Grig. This is just an example of how easy it is to make synthesizers in Grig. But you know, I've got like 2 envelope generators on it. One affects the depth of the frequency modulation. The velocity also affects that. So it's yeah, yeah. Oh shit. Yeah. Let's just fall down. I spilled this water. Yeah. I hope I'm not causing an electrical hazard here. Okay. Well, anyway, I think questions are more important now. So, anyone have any questions? Or did anyone want me to go further into the dive into how the examples work? Sorry. Yeah, I mean, there's, I don't think that anything in here is necessary to do dynamic music in the game, but, you know, like, if what you need is just the ability to generate, like, the notes and stuff like that, there isn't that much in there yet to do that, but as there's more, like, music theory stuff, it could, in theory, be used to do that. But that is part of the idea is I want, you can use, if you want to, like, do something like, have a synthesizer playing as part of the song and have that modulated by the environment. That's one of the reasons you might want to have a synth embedded into your game. And what's cool is a lot of computer musicians obsess over like really complicated synthesizers because of all the possibilities. But the truth is, even with like a 2-operator synth, which is pretty easy on the processor, there's like infinite sounds you can make even with just 2 operators, you know. So that I think there are a lot of potentials there, you know, if you want to modulate, and that's kind of what I plan on doing in the game I'm working on. That's part of why I started working on this. So yeah, definitely, that's one of the use cases that I want to target. Yeah.
Not that I know what I'm doing it. It's the things that I do a lot of interactive toys.
Hmm.
So
Yeah.
I use a lot of sound analysis. Um, say, my
Yeah, that's kind. Yeah, like this doesn't. That's kind of where the kind of utility stuff that isn't there yet comes in. Like being able to do like FFT. That's kind of what you need to do first to see like the frequency content of your signal and start doing stuff like that. But being able to have that sort of stuff in Haxe would be freaking cool because then like all these different environments, you would suddenly have that ability. So often, like I'll find like a lib that does something like that, but it's like I can't use it in the browser, I can't use it, or it's just C++ only or whatever. Um, And yeah, and a lot of that stuff already exists, but it would be cool to have that in Haxe. That's kind of where the next phase comes in. Yeah.
One of the things we talked about was massive work and getting the next.
Yeah, yeah, yeah.
So you're writing, although you're writing a library, you're writing also an application in the library that helps.
Hmm.
And that's cool. Took care of it, and I know the ran it shared above. So what would you think on the math library side? What do you see that maybe missing on the next time?
Well, that's basically the min and max. Just in general, there's a lot of like basic things, basic audio things that would be facilitated by having that. Um, because just like being able to do like converters and stuff like that, or being able to write just any sort of generic audio algorithms, it's easier if you have that, I think.
So if you have some ways you're doing that is more fun than a dumb part.
Oh, yeah, that's not, I'm not talking yeah, that's a little different. Like, what I'm talking about is like the minimum and maximum values that value type is capable of holding. So like you can, depending on the platform, if you can calculate it or whatever, you can do like math.power or whatever, then, but sometimes it's like you have to know some things about the target, and that might be why Haxe doesn't have that. Like I don't know if I can assume what the min and max is for it on like say JavaScript. I actually don't know. So it might be something that has to be runtime on some targets and compile time on others, but yeah. Yeah. Oh, yeah. Yeah. I mean, yeah. A floating point should be able to represent any of um, those values. It's just, it'd just be cool if I knew that at compile time, or at least at runtime, without having to like code it, without having to hard code it in myself or whatever. Yeah. Oh, yeah. Yeah, I mean, if I'm just targeting CPP, I could make externs for a lot of that stuff too. I could probably there's probably a way I could make an extern for numeric limits if I needed to. It'd just be cool if I also had that in JavaScript. Although maybe it won't work right. It's hard. I have to look more into how the implementation works.